name entity recognition, NER model. What do you mean by name entity recognition? Let us suppose if you give a text, document, in that you want to know what each word means. Is that this word is a person name? Is this word is a date field? Is this word a location? Is this word a company name? If you want to know that, you can use this name entity recognition model pipeline function. The task is NER, stands for name entity recognition model. Now there is an extra command that we need to add, that is aggregation strategy, because this output is very confusing. So that is why we have to use aggregation strategy. Simple. If you say aggregation strategy is simple, then the output will be slightly readable. Okay. So once I define this model is getting downloaded. And then I'll say my sample document. My sample document is, let's say there's a mail that somebody has written. Hello. I, John Smith, a member of this. And then 2024, I guess, comma, right. This is the mail that somebody has written. Now I can ask, what are my entities? So I will say my name entity recognition model, NER model. My sample doc will be the input. So NER model sample doc, print all my entities. These are all the entity. Entity group is person. Score is this one. Word is John Smith. Entity group is person. Word is tech innovators. Entity group is organization. Word is Mary Johnson. Entity group is a person. San Francisco is a location. Cafe Bella is an organization. New York City is a location. Remember, building a model like this, name entity recognition model, on our own, internally, inside our organization, it was a Herculean task. You spend 2 months, 3 months, 4 months, 5 months, 6 months on building a model like this, and later on you realize your accuracy is 60, 70% only. But nowadays with these transformers, we can use the ready-made models, and these models are downloaded into your local system. You can save this model. You can save the weights of this model. You can pass on this model. This is a physical model, which is literally downloaded into your system. You can save it with whatever name that you have. But only thing is we have to see the licensing. Sometimes some models have different licensing rules. So somewhere in this, there is one licensing information also given for some models. I think if you go to models, so there are different licenses that are available. Apache 2.0 is like almost completely open. That means you can take it without mentioning anybody. Like this is like freely given. CC is also like that. Some of the models, if we are using, we have to give them the credit, not necessarily money. We have to tell that we have used that or something like that. These are different type of licenses. We have to see what are the licenses that our organization is accepting us to use. Okay. Some of them are their own licenses. We have to follow their terms, then only we have to use them. So it's not necessary that you can use any model that is given on the Hugging Face. You have to check the license. I'm talking about the organization. If you're working in a company, can you use a Hugging Face model? Check the licensing rule. If the license is okay, like most of the licenses are open source only, Apache. Let's say Python is an open source model. You can use it in your company. So they have given Apache license. So similarly, the license that is allowing you to use, you can use that one. So we can get all this into a different data frame also. Like this doesn't look good for reading. We can store it in a data frame. Let's say my NER result is equal to, I'll say entities, and I'll just take word and the entity group. That's it. Nothing else remaining. All if I ignore, simply this is the word, this is entity, this is the word, this is entity, word and entity, word and entity. This is one of the model. You have text summarization models. You have text generation models. So there are like literally whatever is the task that you're thinking of. Usually what we used to do in our, like until now in our life is, if I want to solve a problem, I would like to collect the data. I would like to build the model, fine tune the model, make the model better, working on our data. Everything we used to do it from scratch. But today I'm going to break that. Never build the model from scratch, or there is no need for us to build all the models from scratch. Sometimes the task that you are thinking, maybe there is a model that is working much better than whatever you can do already. It has been built on large amount of data. These are all large language models. These are all transformer based models. A large language model uses large amount of data. A transformer is a very deep neural network which uses multiple parameters. Automatically they will be very accurate. Let's see an example of text summarization. I'm not sure whether you will be using all of these, but the reason why I'm showing different examples is maybe you require a task that is much different than whatever has been discussed in the classroom. Then check whether that task can be fulfilled by using any of the task that is given here. And then try to use this approach. You define the model using pipeline function. And then let's say once you define that model, let me give some text, which is, let's say, book essay is the text that I'm writing. The 7 habits of highly effective people is a book, is a, let me get that text directly. This is a sample document. This is the book that I'm talking about. Let's say this is an essay that we have. Now I want to summarize this. All that I need to do is simply summarizer model. What is the model name that we have given? Summarizer model. Summarizer model. Then I will write my book underscore essay, comma, max underscore length. Maximum, what should be the length of the final summarized version? I would like to have 120 tokens or 120 words, roughly, you can think. Minimum to minimum, how many you want? Minimum length. Minimum length equal to 30 words or 30 words. Now I'm telling the model to use, let's say, when it is summarizing, it can have any amount of summary. So minimum to minimum 30 words are required. Max to max 120 words are required. When I say that, then it will try to summarize it. This is the summarized text based on whatever is given here. Obviously, the accuracy of the model depends on whatever is the model that we have picked up on. These are all simple examples that I'm showing you. Later on, we are going to choose the models that are highly effective, that are giving very accurate results. Here, maybe some of the models are not working effectively. We are trying a couple of models. That's it. We are not really worried about the accuracy at this point of time. We are just kind of experimenting what are the different options in the pipeline function in the transformer library that we can do. One last exercise that we do, which is a text generation model. Let's say my text generation model. Text generation is the task keyword that you have to give. I'm using model GPT-2, and then once I do this, we will go here, my text underscore generator model. So my text generator model. So what I wrote is the best way to start a presentation is. So this is just a warning. It is saying pad tokens and end of tokens, etc. The generated text is the best way to start a presentation is to talk to people and ask them some questions for 6 weeks by meeting a person, she said, etc., etc. Basically, the accuracy again depends on what model you are using. Let's say if you want to change that model, all that I need to do here is I'll go to text generation, and then I will choose the most downloaded ones. This is the GPT-2 is the most downloaded. Let us take this one. Is it a closed model? No. So I will use this. I'll come here. I'll paste it here. The best way to start a presentation is to use a PowerPoint presentation. So it depends on whatever is the model that we are using. The previous one was much better. I'll use one more and then we will just leave it. Meta Llama. This is the model that we'll try to use. Instruct. So whenever you want to use a different model, you come to model and then change the model name. Is this a text generation model? No. Let us see what is the error. Client error. You're trying to access a gated repo. What does that mean? What do you mean by a gated repo? Gated repo means this is a gated model. You have been given access. For me, it has been given access. For everyone, it may not be giving access, but you have been granted access to the model. That means I have granted access. That means I have to give the key for Hugging Face, etc., etc. That we will see later on. Right now, we will not go with gated models. We will go with ungated one. Let's see Distilbert GPT-2. Gated model means we have to get the permission. We have to make sure that we are our ID. Model is getting downloaded. And then if I try to do summarization, oh, that is text. Summarization. This one is this one. Text generation. The best way to start a presentation, still make sure that your face is properly in shape, so you can material stand and cut, etc., etc., etc. So these are some of the examples that I have shown, but these are not all. There are several other tasks that you can see. Different tasks can be done here. So everything is happening behind the pipeline in our case. So execute all these pieces of code. Once you're done with these until here text generation, give me a confirmation in the chat window. We'll proceed. Maybe when you're writing the code for the first time, it may be a little confusing, but from the syntax point of view, it is not that complex. All that we are doing is we are calling a particular function with certain parameters, and then we are using that function for making a prediction. Right? Done? Have you executed until generation part, text generation? Done? Yes. So until now, whatever we have seen is behind the pipeline. That means when we gave the raw input, this pipeline function is writing a couple of lines of code internally to convert the data into text tokens. That is known as encoding or the tokenizing. And that encoded text is sent to our model. The model gives the output in a probability format. Or let's say if you have 15 nodes or 20 nodes in the output layer, you will get all the 20 outputs. But those outputs, we have to take them and we take the max value, the class that contains the maximum probability, and we have to give that. Like that is also the post processing is also taken care by pipeline, and we are getting final output. So we are giving the input to the model, we are getting the output, but pipeline function is taking care of it. It is doing two tasks. It is doing the pre-processing of the text. It is doing the post processing of the final model output. But without pipeline function, you have to add one or two extra lines of code. In some cases, slightly higher number of lines of code for pre-processing, maybe one or two, or maybe a small function that will do the post-processing. This need to be done without using the pipeline function. So without the pipeline function, the code will go like this. We have to use something called tokenizer. And this tokenizer will convert the data into tokens or some kind of encoded values that model can understand. That tokenized text need to be given to the model. And then the output comes. Then we have to write this code, a function that will understand that output, the output, model output. And then logits is like kind of probabilities that we get from the model. Then logits need to be converted into the final class. 0 means negative, 1 means neutral, 2 means positive. Until now, we used to get this output directly, but this was done by pipeline functions automatically on its own. Like, let us suppose if you're not using pipeline function, what is the process? Let us see that. So this is without the pipeline. So I'm using the tokenizer. First, we have to tokenize the data. So you have to get that tokenizer and the model. This is the way we have to convert the output. So right now I have given the raw text as this is a great book. Now, so we have to divide this into 2, 3 phases here. So this is the input. This is the input text, raw text. And then we are tokenizing the input text. And then what are we doing here? Output equal to model encoded input. What's happening here? This line of code, the below line of code here, getting the predictions from the model. And then once you get the predictions from the model, the predictions are not straightforward. The output will be like a tensor or the output will be like a large vector. So those need to be converted to logits. And then we have to use something called argmax. What that argmax will do is if you have 10 nodes in the output layer, you will get the 10 output probabilities or 10 output logits. Then we have to take the class with the maximum probability. The class with the maximum probability need to be taken. That is that argmax doing. And then finally the predicted value. So this is a great book is given as 2. That means it's a positive. We have to check what is positive, what is negative. Let's say if you go to this Twitter Roberta base sentiment, if you go to this one, so here 0 means negative, 1 is neutral, 2 means positive according to this model. Let's say if I say this is not a good book, 0, 0 is negative. So the output will be 0, 1, 2. Now why we need to handle without pipeline? We need to handle without pipeline if you want to fine tune your model on your custom data. Now this is the real meat of this whole discussion that we had until now. Until now, I have introduced different large language models that are freely available. These large language models, you can download them, you can work locally on your own system. Now the next task is, yes, I have a large language model, but it is not fine-tuned on my data. Yes, it is a very huge model. I agree that it can give a high accuracy on a generic data. But if I'm working with a very fine niche data, I'm into a bank, I'm into credit risk. Within credit risk, I have a particular feature, I have a particular function. The kind of text that I get is very niche to my team. Within my bank also, this is a very different team and this text is very much related to my team only. Then how do I fine tune? I want to use the reasoning power of that large language model, but on my data. If you want to do that, what is the procedure? Let us see. Remember, on day 1, we discussed there are certain phases as a generative AI data scientist you will be going through. The first phase is building the models totally from scratch. The complete model. You're building a complete model phases you have taken. That's what we have done in our previous exercise. We have taken our data, we built a complete model on our own. This is what the world has been doing until now. We collect the data, we pre-process the data, we build the model, we fine-tune the model, we run it for multiple iterations, make sure that not overfitting, not underfitting, we finalize the model. This is what we have been doing. This is what the whole world is right now. The second method is you give your data to a large language model and ask right questions. Then you may get good answers. So you have to ask right questions. What is asking a question to a large language model? What is that process known as? Prompting. You give the right prompt or prompt engineering. That is the second phase. So some people are still here building the model, everything. In some organizations, we have a large language model. We can buy the large language model. Some organizations are having tie-ups with large language model providers and then giving a prompt to get the output. That is one way. The third one is what we are discussing. I will take a large language model. I will expose my data and fine tune it for my data. For example, now this is the third phase. For example, somebody, let's say Raj, has built a model in his company. Let's say his company A. He has built a neural network model. In that, he used a input layer, hidden layer, or multiple hidden layers. Deep neural network model they have built. Hidden layer 1, 2, and so on, hidden layer K. And then the output layer. This model has been built by Raj. Okay. Now, apparently, what I have observed is Raj's model is quite good. And the accuracy of this model is almost 99% on wide variety of data sets. Like they have built a model on credit risk data. And most of the credit risk data sets, it's working perfectly. I'm talking about the natural language processing model, NLP based model. If I want to use Raj model as it is on my data is also credit risk data only, but it is slightly different from Raj company. I am working for company B. My data is slightly different. Now, what I can do is maybe in company A, they have worked with a team of 10 people. They have taken 1 year to build this highly accurate model. 1 year. And it's all worth. After 1 year, they can make accuracy of almost 99%. Now, I have to once again spend 1 year. I have to get hell lot of data. I have to take care of a lot of processing, etc., etc., etc. It's a Herculean task. What you can do is you can take, let's say, if Raj allows that, if they make this model as open source, If this company makes this model as open source, what we can do is we can take this data, or we can take this model, and we can supply our data. Take this model means we download this to our local systems. Download it because it's anyway open source. You download this model to your local systems, and then you supply your data. Usually when you are building from scratch, you start from random weights. Do you remember neural network? You start from random weights and feed forward, back propagation, all that will happen. Instead of random weights, you start from the weights that was given by company A. That means already it is very much a good model. But by exposing your data, by starting with those weights, you are adjusting those weights. Adjusting those weights is nothing but fine tuning. That means the same model with different set of weights is now fine tuned for your data, and you do it until you get on your data until you get 99% accuracy. You can train this model. Maybe as it is, if you use, you are getting 70% accuracy only because it is not fine tuned on your data. By fine tuning on your data, you can push it to 99% accuracy. You don't need to really build it from scratch. You don't need to worry about building this model. You don't need to worry about spending 1 year time. So model fine tuning means changing those weights. That is our next task. That is the taking a large language model from Hugging Face, exposing our data, fine tuning it so that we can get the best results. That is the third task. Maybe a lot of companies can try this. They are trying this. This is a good option. What we will do is we will discuss about it. But before that, we'll take a quick break and then regroup. Okay. Let's take a break for 10 minutes. What we are going to learn right now is transfer learning from Hugging Face models. What is transfer learning? I will take an existing model, and I cannot expect this model to give me best accuracy on my data. My data is very different. The model has been trained on the whole world of data. The model has, like, my data is only related to particular credit risk. This model has been trained on marketing data. This model has been trained on Twitter data. This model has been trained on news articles data. On the whole world of data, the model has been trained on it. And it has used a hell lot of information. So it will have good inferential properties. The model will have good reasoning ability. But particularly, specifically, very niche on my data, it may give very poor accuracy. So model is powerful and model is quite big. But can it work on my data? It may not. So what we will do, without fine tuning, if I try my data, maybe I'll get something like 60% or 65% accuracy. I will take this model, I'll download this model, I will send this data, and I'll run 1 or 2 more epochs on top of it. I will write few more epochs. I will run few more epochs. That means I'm changing the weights of that model. By changing the weights which are suiting to my data, I will be able to, I can expect better results out of it, or at least I can feel that I'm doing something to this model that is kind of being adjusted based on my data set. Let us see one full procedure of that right now. If we go back to our data set, so this particular example that we are talking about is this CFPB, Consumer Financial Protection Bureau. This is one of the data set which we already have used earlier. This is a US based forum. It is like our consumer forum in India. In US, anything related to your financial institutes, you can go and give your report, or you can give your complaint here based on credit reports, debt collection, mortgages. So a bank has collected extra mortgage from you. If you want to raise that as a concern, you can come here and you can actually make a complaint here. So everything in this data is a complaint. Now the data looks like this. So for us, you have complaints related to credit cards, you have complaints related to retail banking, you have complaints related to credit reporting. Most of the complaints are related to this category called credit reporting. So to make this simple, I have kind of combined everything into 2 classes. So class 1 is credit reporting, class 2 is credit card, retail banking, etc., everything other. So class 2 is other, class 1 is credit reporting, just for the sake of simplification. So what we need to do is, all these are complaints only. Now this is text classification. But if you give this text classification to the pre-existing model, the model will automatically do sentiment analysis, positive or negative. Apparently, everything in our data is negative only. So the model will definitely fail. So if I use any text classification model from Hugging Face as it is on my data set, let us see what happens. So I'll go to that particular case study. This is there is a little bit of code involved in this. What I have done is I have given a very detailed code line by line explanation on my GitHub page. Everything one by one line, every function, what it does, every line of code, because it will take a hell lot of time for us to go through each and every parameter. But later on, when you are going through your assignment, when you want to understand this code, I have given a very detailed, lengthy explanation here. You can go through it, and multiple options also I have added beyond this code. Okay. But here we will see what are all the the important conceptual understanding we will try to get out of this data. So this is a data set, complaints data. So you have credit card related, retail banking. These are the first 5 rows that I'm printing. So this is my target. My target label is either 1 or 0. 0 means credit reporting, 1 means others. But if I use directly a model without any fine tuning directly as it is, if I'm using Distilbert base uncased model, and my task is text classification, I just need to classify this text into 2 categories. Either it is credit reporting or other. Tell me honestly, do you think the model will be able to do this classification automatically without me telling? Zero shot, is it going to work? Zero shot is almost like first guess. What will be the first guess from this model? Is it going to guess whether it is credit card related? Is it going to guess whether it is retail related? There's no way, isn't it? It will do whether it is positive or negative, positive or negative. Apparently, these are all complaints. All the complaints are negative only. So automatically it will predict everything as negative, negative, negative only. Nothing will be predicted as positive, or very rarely one or two will be predicted as positive. I have taken a sample data here for the sake of demonstration. Otherwise, for large data, it is taking a lot of time. So these are the BERT predicted numbers. These are the actual labels. In BERT predictions, everything will be 1, 1, 1, 1 only. 0 means positive, I think 1 means negative. So everything is predicted as negative. If you want to see the accuracy of the model as it is without doing anything, you see nothing was predicted as positive, everything was predicted as negative. 53% is the accuracy. Obviously, this is no way close to what we are expecting this model to do. We are expecting this model to take our data set and find out what class it belongs to. The classes are not positive and negative. This is not a sentiment analysis model. No, this is a model where we want to divide. Based on every comment that we receive, we want to divide whether it is related to credit reporting department or other department. In fact, we can make it to all the departments like credit card or retail banking or credit reporting. But as of now, I want to do it into 2 classes. Now, how do I tell my model that, you know what, you're not supposed to do sentiment analysis here. You're supposed to take my classes as output, and you're supposed to adjust your weights in such a way that you can make this prediction. How do you do that? That is known as fine tuning of that model. So let us see the process of fine tuning. First, like here, I'm reinstalling everything just to make sure that like this particular code that you see here, maybe you can reuse it later on. That's why I have kept everything once again. So these are all the packages that you require. These are the, once again, we'll try to install so that you can take this code from here on. You can copy it directly from here just by changing the data. You can implement it on any other new data set that you may get in future. So imported the packages, install the packages, imported the packages. Here, I'm not taking the full data because the full data is taking a hell lot of time. The reason is all these models are large language models. It's not millions, it's billions of parameters are there. Now, obviously, it will take at least 8 or 9 hours for us to execute that model. Maybe each epoch may take 1 hour each because billions and billions of parameters are there. We don't even have GPU with us. So that is why I have taken a small data set, sample data of 100 records. So here what's happening is we are converting the data into some Hugging Face friendly data sets. Until now, we used to work with pandas data. The sample data is a pandas data frame, but we have to convert it using datasets package from pandas into some, these are kind of Hugging Face friendly data sets. They are converted into some data dictionary format or something. And then we have to get the tokenizer. And then what is this? Padding does. Padding is going to take each comment. If we say maximum length is, let's say 250 characters or 250 words, then if a comment is beyond 250 words, it will be cut until 250 words. If a comment is having less than 250 words, it will be padded. Padded means extra spaces will be added. So once the data set is padded, once it is tokenized, tokenizing means converted into numbers, and then padding means adding the extra spaces, making everything uniform. Then what we will do is we will load the model. I will say, take my Distilbert model. Now I'm mentioning my number of labels are 2. Distilbert originally is a multi-class classification model, but here I'm saying my number of classes are 2, 0 or 1. If you are having more number of classes, you have to mention it here. If you are fine tuning on a data set where there are 6 different classes, then you have to mention number of classes equal to 6. And pad tokens, I want to pad them. Tokenizer equal to this one. Basically, padding means I want to convert everything into the same length. Some people have written a review of 20 words. Some of them have written a review of 200 words. I want to convert all of them into one particular option. And this is the model here. It has huge number of embedding layer and then positional embedding layer, normalization, dropout layer, transformer layer, different layers are there. This is a huge model. This is a model that is having nearly 67 million parameters. If we go to this model, Distilbert base uncased on Hugging Face, this is a model that is having 67 million parameters. So obviously we are working with a large language model which is having 67 million parameters. Disturbing it and running it for one epoch itself is going to be a Herculean task, because we are working on a general CPU without any GPU. There is no parallel processing that we are doing, and disturbing all those 67 million weights with our data. 67 million are the weights. The number of calculations will be even more huge. So that's the reason why I'm working with a small data set. Maybe we will try to increase the data depending on what is our final accuracy with this data, with whatever is the small data that we have taken. These are the training arguments. What is the output directory? Where do you want to store the final model? Where do you want to store the log files? This is a place where I want to store the log files. Right now I'm running for one epoch only, but in future you may have to run for multiple epochs. Maybe with one epoch, you're changing the weights a little bit. If your purpose is solved, earlier what is the accuracy? Earlier the accuracy was somewhere around 53%. My accuracy target is only 80%. If I reach 80% accuracy, I'm fine with it. I'm not really looking for 99 or 98% accuracy. Maybe with one epoch that is achieved, then we can stop it there. Okay. Now, finally, this is the place where you're actually training. You're building a model. You can almost consider this as building a model, but not from scratch, from a previously existing model. You have taken the model already. This is known as transfer learning. A model has been trained on something else. You're transferring all that knowledge. That means you're taking all those weights and with your data. So I'm taking the model, which is Distilbert. I'm giving all those arguments, which are like, where do you want to save the model, etc., how many epochs, etc. And I'm giving my data set. This is my data set that I want to give. I want to retrain this model by using my data set. And then this is the evaluation data, which is optional. Once you say model.train, the actual model building process will start here. Obviously, it is time consuming. It is going to be. So it is one epoch I have executed. Here we have taken hardly 100 records. That is why it has executed quickly. With 100 records, we may not get good accuracy, but okay, once you save that model, once you build that model, now you're saving a physical form of this model. So here you have these files. Once you say my model directory is Distilbert fine-tuned, which is not here as of now. Okay. So you can save the model. This is a physical file. The model directory name that I'm giving is Distilbert custom model 10K. So if you refresh it now, so this is a Distilbert fine-tuned Distilbert custom model 10K is the model that we are building. This binary file that you see, this along with these safe tensors, like this is the actual model extension, like 255.43 MB. This is the actual weights file. All these 64 million weights, all of them put together are in this model. This is my physical form of the model. This, I own this model. You own this model. Nobody owns this model because we have trained on our data set. We can keep it in a secret place wherever we want. And then from that model, we have to make the predictions. So this is the code for making the predictions. It looks a little complex, but in simple words, we are giving the new complaint and taking the, like sending, tokenizing it, and then sending it to the model, getting the predictions, and then getting the predicted class out of it. For the sample data, these are the PERT predicted numbers as it is. These are the fine-tuned predicted values. And what is the new accuracy from the fine-tuned predicted values? The new accuracy is 54%. Obviously, it will be very less because I have worked with only one epoch. More importantly, I have worked with only 100 records. By exposing 100 records, by working only on one epoch, I cannot expect it to give me very high accuracy. Try to start with 100 records, make it 1,000 records, 5,000 records, 10,000 records. And then once you give 10,000 records, if you run 4 or 5 epochs, then you may get a better model. That's what I have done. So outside this classroom, what I have done is I have given 10,000 records to this model. It has taken nearly 3 or 4 hours to execute because 67 million weights, 10,000 records, and 4 or 5 epochs I have executed. You can load the model onto CUDA, but if you do not have the GPU, you have to say CUDA equal to 0. Like you have to ignore this particular one. So this is the model that I have trained. You can take this, like by using this, we can download this model. Now I am saying model version 1. I'm loading my model that has been fine-tuned. Okay. This is the final model. Now I'll use the same function for making the predictions. What I'll do is I'll try to make the prediction for 1,000 records. Prediction also itself takes time because 67 million weights, every input review that I'm giving, it has to go through 67 million weights, then it will give you the final predicted value. Now I have stored them in fine-tuned predictions. It will be 0, 1, 0, 1, etc. Now if I see the accuracy of this model, 87.7%. We started with a model which is 50% accurate, which is almost like a random guess. Everything was predicted as negative, negative, negative. But now we have fine-tuned this model. That means we have taken the existing model, we have exposed our data, and then run it for a couple of epochs. So while you're exposing your data, don't expose all of it in one go. First give 100 records, then go for 1000 records, see the accuracy, then go for 5000 records, see the accuracy. Sometimes exposing 5000 records is sufficient. Then go for 10,000 records. Maybe depending on the complexity of your data, depending on the speciality of your data, you may have to give how much ever data that is required for the model to understand. And if the model is giving satisfactory accuracy, then go ahead, approve it. For me, 80% itself was good enough for me. I got 87%, 87.7% accuracy on the data set, train and test data both. Then I will go ahead, use this. Have you understood the process of fine tuning, all of you? A lot of companies right now are doing this task. Let's say as a company, I cannot build a large language model on my own. So that is my problem, because it takes a hell lot of time and we may not have the technology infrastructure. As a company, I cannot use some other company's large language model inside my system due to some various policies and reasons. Let us say I am a bank. Let's say my company name is Bank of America. Now, I cannot build a large language model because it is a time consuming process. I cannot use an existing large language model as an API from OpenAI or Google Gemini or Copilot. I cannot use them because some of my regulatories have told that there is no way you can send the data. There's no way you can expose the customer data to any of them. Even you can explain it to them that the data will be encoded into numbers and given, but still they may not approve. So building a large language model is not possible. Taking the data from an API, that is also not possible. In these cases, what you need to do is you download an open source model. That means you are taking a base model and then you are fine tuning. I think in some of the companies, this is the process. Like not every Gen AI problem need to be solved in a grand manner. Not every large language, like not every place we have to build a large language model, or to solve every problem. There's no need to use the API, or there's no need to use advanced techniques. Sometimes this is sufficient. I have seen a lot of people solving the problems just by using this Hugging Face fine tuning. Are you with me, everyone? Are you getting what I'm trying to say? Now, some companies, what they're doing is they are creating some spaces on some Hugging Face. Like on Hugging Face, you can create some personal spaces. Like when you log into Hugging Face, right now we are using Hugging Face model using this option, right? Let's say if there's a model on Hugging Face, you copy that. Now, this is a public model. Now, if you're a company, you can create a private space on Hugging Face. Let's say you're from Bank of America, it will come as Bank of America -Distilbert -fine-tuned. Now, nobody beyond Bank of America will be able to access it. There will be some access token that will be given. Once you use that access token, then only those are like kind of gated models, or those are very much private models. Those models will be used only by that company, by that particular group. So what you can do is your company, your organization, some team will build it, and then everybody in the organization can use it just like the way you can mention the task. You can mention, so this particular one, you will copy it here, you'll paste it here, and say here before that, maybe your company name followed by team name will come into the picture. That's it. And this will be private. Nobody will be able to access it. If anybody tries to access it, they will get an error saying that you do not have access to this model, or like I have seen one error, right? Earlier, we got an error. This is a gated model. You are not supposed to access this or something. That kind of error will come here. In fact, the model that we have built here, that can also be pushed onto Hugging Face. Let's say I have built this model. I have built this model, and now I feel that 87% accuracy is good enough. Now this model is quite heavy to carry. From 54%, we got it to, let's say, 87%. Now this model as it is quite heavy to carry. And how do you share across the teams? How do you put in a particular place that everybody can use this model? In our team, 20 people are there in India, 20 people are there in US. How this model being used? Where are you going to store it? You can actually push it back onto Hugging Face Hub. You can push it back onto Hugging Face Hub. For that, you need your access token. That means you have Hugging Face from here. If you go to settings, there will be some authentication access tokens will be there. You can generate a new token. Once you have the token, then what you can do is you can push this model. So there are some models, like these are the models that I have pushed. So what we can do is simply, we can use this link. You can make these models private. This is, right now for me, it is private. If you want to make it public, you make it public. Now I want to make it private. So this is a private model for me. So I can access this model, only I can access this model, given that that particular access token is given. And then I will, once you push it, you can use the model like the way earlier we were calling it from Hugging Face, like the way you were calling, you were taking any Distilbert model. Similarly, exactly the same way you can access this model. The model name will be my name followed by this one, or your team name followed by this one. So this is my model, the model that I have built in May. And then you can get the prediction, whatever is the prediction that you are getting. So in some cases, I have seen some companies, they have created their own Hugging Face spaces where they're all team, because this is already working like a good GitHub repository, and there is a lot of documentation. There is a hell lot of code. It's very, very easy. So because of that, there are some schemes. Obviously, it's not free. We have to pay for it. But there are some schemes where you can load all your teams onto the Hugging Face. So some companies are like, this is very, very secure. If a company is using GitHub, there's no reason why they should not be using Hugging Face. It's a very secure one. Otherwise, we have to create something like this, some repository like this internally in our company where we save the models there and access them. Or the brute force method would be, take this physical file of this model. Whenever you're loading it, load using this option. So what is option for loading the model? So this is a physical file of the model. And then you say my model from pre-trained, mention the path where the model is there. So this is my path, Distilbert custom 10K, fine-tuned. This is the one that will be loaded. Either you load it physically using a file like this, or you push it onto Hugging Face and then access it from there using your whatever is the access token. You can get the access token from Hugging Face Hub and then use it in this manner. So as I told you, it is not necessary that always you have to use a very high-end API. Sometimes we may have to fine-tune our models using Hugging Face models. So the process is, you take your data, you study your data very well. You study your business. You study the business, you study the data. Then what you need to do is, you need to go through all the Hugging Face models that are available. That is the standard ones. See which model suits best for your data. See which one is near to your data. And then take that model as the base model. And then do this transfer learning, do this Hugging Face model fine tuning. Then you will be able to get good results out of it. Maybe try it multiple iterations with multiple number of rows. It may be time consuming. Definitely this process may take 1 week or 2 weeks, but this is much, much far, far lesser than building a large language model from scratch. So what I have done is, which is an optional one, last one is optional. I have created a kind of a web application by using this particular model that we have built. So what I have done is, I have created this web application where we have to write all the requirements. Requirements is nothing but all the packages that are required. This file need to be created. And then I have used Streamlit, which is a web application creation package, which will help us to write this website front-end code quickly and connect it to our models. So I'm creating app.py and then I just load it. This is optional, you may not be requiring to do this. But finally, if I want to create a web application where the customers can post their whatever is the issue and see which class that it belongs to, that is also possible. Not necessary that everybody will be creating a web application. Sometimes the models that we have built, they never require a front-end user interface. Sometimes the models just take the input data batch-wise and process it. So for example, if I give this as the input, it must say it related to credit reporting. If I give this as the input, it must say it is related to others, mortgage and others. So that is a fine-tuning part of the Hugging Face pre-existing models. So that concludes our session here, where we talked about using the Hugging Face models as it is, which most of the cases people do it. If you are working with generic data, what do you mean by generic data? If you're talking about sentiment analysis, no matter what is the background, no matter what is the business, positive sentiment, negative sentiment, whether it is e-commerce business or whether it is banking or whether it is automobile, whatever is the business, I think sentiment analysis, we can use these generic models, Hugging Face models as it is, you can use them. But if you're talking about very niche problem statements like this, where I want to divide them into whether they belong to department A, department B, or department C. If you want to divide them into very, very niche classification related to your data, then you may have to fine tune. I have shown the fine tuning of text classification like that. Depending on your task, you may have to follow the fine tuning of that particular model that is doing a different task for you. As usual, we will have an assignment on this, and the assignment will be, as usual, slightly difficult than what we have done here. So before doing the assignment, I request you to go through the class video once again, understand the code once again, then you go to the assignment. Then you should be able to resolve the questions that you're getting in the assignment. And write the assignment questions in the group. I'll try to answer them there and then. Okay.